Yeah, good evening to one and all. Today we are going to discuss our next concept here as welding, the two electric welding. It's an part of utilization of electrical engineering subject. In the last session, we covered some heating, and thereafter we'd like to go for the part of welding. Just try to concentrate here. Yeah, what's the main definition for the part of welding here is I just want to join two metal pieces here. Yeah, technically we may call it as these metal pieces. We already call it as work pieces here. Whereas in terms of heating, we may call that material to be heated, maybe call it as charge. Yeah, don't neglect these words here. In terms of heating, whatever may the material you have to heat it, that may be called it as charge. Whereas in terms of welding, we have to join some metal pieces. Now, those things may be called it as work pieces. Yeah, it's a process of joining two metal pieces in which electrical energy is used to generate heat at the point of welding in order to melt the joint there. That's the only line you have to write. I'd like to join some two work pieces by creating some sort of heat energy with the help of electrical part at the point of welding there in order to melt that piece, and we can join those things there. Yeah, mainly we are having some two types. One thing is nothing but resistance welding, another one is nothing but arc welding. In terms of resistance, we are having some spot welding, seam, projection, butt. Whereas in terms of arc, we are having some carbon arc, hydrogen arc, argon welding. All these are some basic lines. But try to remember one thing. Whatever may be question you can have, we can pose in the examination point of view. Just remember, you have to write these two basic lines there. In terms of resistance welding, just try to remember whenever a current passes across some material there, workpiece, I would like to choose some WP stands for workpieces. I would like to join these workpieces there. Yeah, I'd like to pass some current and we can create some sort of energy there. That energy may be called it as heat energy. According to the part of which thing, Joule's law of heating, I square RT. As well as we have to apply some sort of pressure there. In order to join those two workpieces, we create some sort of which thing here initially, heat energy, and also we have to apply some sort of pressure in order to join those two workpieces here. Heat energy generated at the joint is sufficient to melt the part of metal pieces. There it creates a sort of weld. The type of welding may be called it as resistance welding. Yeah. What sir may the welding we can have it whether it's a seam welding, spot welding, butt welding, everything you have to write this basic line. Joule's law of heating I square RT. We create some heat energy as well as we have to apply some pressure in order to join those two workpieces. That's the basic line. That's it. Coming to the part of arc welding, we can use some principle here that may be called it as ionization. Ionization is nothing but I would like to have some electrons will enter or else electrons will leave. If electrons will leave, that may be called it as positively charged. If electrons will enter, maybe call it as negatively charged. And it can create some sort of ions. In between, I would like to have some two metal pieces like this. I would like to create some strong electric field in between these two things. When I would like to have some ionization process will be there, that it can have some electrons, and it can create some sort of ionization process, liberation of electrons, and it can form one path there. It forms will resemble the part of which thing arc structure. Yeah, and it can create some sort of heat energy with the help of formation of this entire electrons may be called it as it forms some current. There you can have some I square RT similarly. But the process here is ionization. What's that ionization is nothing but it's a generation of charged particles, whether it's a negative or positive in the welding arc. That it is what we are having some electrode and we are having some workpiece. In between these two things, we create some sort of plasma having some temperature of how much here? 5000 degrees centigrade. This one is enough in order to have that metal melt has to be done. Then it can have some process. Joining of these two things will form with the help of some arc. That's a basic line here for the part of which thing? Arc. Observe this thing. It creates some sort of arc like this, formation of some current path. Free flow of electrons may be called it as current. That may be called it as I square RT. There we can have some heat energy. That heat energy is enough for the part of melting and joining the part of which thing? Workpieces. That's it. But in terms of arc welding, there is no need of having that pressure, application of pressure. Yeah, that's the line they have written. Ionization in welding creates a conductive plasma in between those two workpieces, and we have some heat energy now stabilizing the arc and making the process efficient by ensuring the continuous heat generation for melting and joining the metals. That's it. Yeah, if you can remember, you can write it, or else you can write these three lines: I square RT, heat energy generation, melting and joining of workpieces is happening. That's the classification wise. The first and foremost classification here is resistance welding, that to spot. This spot welding we can come across in terms of which thing? Automotive manufacturing. Yeah, which type of thing here? This center resistance welding is for the part of which type of supply? AC supply. That we have to remember one thing. This welding is possible for the part of thin materials. Yeah, the mm is somewhat thin. That is small mm is enough there for the joining. I would like to choose some two workpieces, workpiece 1, workpiece 2. These two things I would like to join via the part of one AC supply. Now, compulsorily have to use some transformer. This one is a primary and this one is a secondary. There it can flow some secondary side current, and I can join with the help of some workpieces. There we can have some heat energy. That heat energy across this specific point only there. I'd like to apply some pressure in the lower end, this clamp. Then these two things will join out at this particular point. Yeah, that type of specific point structure may be called it as spot weld. We can use it in terms of which thing? Automotive manufacturing sector. This one is our laboratory wise. We observe this one. We can have some upper electrode, lower electrode, and I can place some metal pieces here, work pieces. Then I can use only the sharp edge at the joining. But I'd like to apply some pressure here across this one. There, these two work pieces will join out only at some specific point spot. In a similar fashion, try to go for the part of next thing, seam welding. Seam welding, we can use it in fuel tanks or also water bottles. In terms of that particular electrodes, I may use some roller structure like this, round structure. These rollers will have some multiple spots there. Multiple spots at a time welding will occur. Basically, everything is common. Transformer is common. And in terms of electrodes, I can use some rolling wheel type electrodes. In between the part, I would like to join these work pieces or metal pieces. And try to remember, don't make it continuously. If you make it continuously, there is some molten state will be there and we can't exhaust that particular structure. That's why I would like to apply one cycle like this, some gap, again second cycle, some gap. Then we can have this particular structure. In between those things, we can have some gap will be there now for the cooling of these things. That's it. Just replace these electrodes with the help of some roller wheels. That's it. Only construction is different. The first and foremost slide is important for everything. This one is for the part of next welding pipes. It's a modified version of the part of spot welding. That may be called it as projection. Multiple welds made simultaneously. Yeah, I can have this structure, multiple things at a time. Moving structure, fixed structure. Transformer is fixed, everything is thing. Projections I can make it and I can have some specific design. I'd like to have this particular thing. At a time I would like to attain these two spots, multiple welds. Only some structure is different. Next one, some flash or else butt welding type. Transformer is fixed. I can have some two electrodes, one clamper. In between these two things, welding metals now. Join these two things with the help of some flash. This one. Same thing. I can go for the part of flash butt welding. It's a preheating structure. We can use it. Same transformer, but I would like to have some two electrodes. Both the electrodes are movable clamps. I can move these two things with a strong arc is there. That it is, it can create some sort of arc. And it can join those two things there, sharp edge. This one may be called it as flash butt welding. It's a combination of resistance arc and pressure, everything is possible. This one is used in mainly in terms of production welding. Preheating purposes, we can use it. Both the clamps are movable. The next one is the main thing, arc welding. Electric arc welding is a process of joining two metal pieces, but try to remember what's the principle behind the part here is. I just want to supply is given across the part of conductors, two conductors like this. I would like to give it some supply. We can create some sort of strong electric field. There is a air gap now. These two things can be ionized with the help of some ionization process. Electrons will form some line like this. It can create some sort of current, that it is I square RT. That heat energy is enough for the part of particular metal is in the part of molten state, and I can join those two things. Yeah, that's only lines they have drawn here. The increase in ionization decreases the resistance part, thus the current increases there with the decrease in the part of voltage. Initially, I can apply some stronger voltage there, then it can reduce it momentarily. What are the different components we required for the part of arc welding here is, main thing, we can have some power sets, we can have some electrode holder and the cable welding, and we can have some workpieces. We have some shield also there, face screen. We can have some hammers, chipping hammers, brush also there, earth clamp and protective cloth. These are the different components we can observe with the help of this slide. This one is a face shield coated like this, and we can have some hammer. We can also have some brush for the cleaning purpose. When I can join these two metals like this, there is some zigzag of manner like this. I can make it some strong structure like this, smooth structure with the help of hammer. Once I can glitter it out like this, we can have some brush to clean this purpose. Yeah, this one is a electrode holder, and we can have some filler material and the metal. Just when I can have this space like this, strike like this with the help of this filler material, we can have some sparks and it can create some arc like this. With the help of that heat energy, we can have them joining those two parts. It is in a zigzag manner, just make it some smooth structure. And make a note, this one is for the part of some previously that resistance heatings with the thin materials. Now this one is for somewhat large materials we can join in terms of size. Yeah, the first and foremost thing, carbon arc welding, everything is common and we can use some ionization process, electrode holder, clamp, and we can have some electrode. That electrode, this one is a base metal I would like to join, and with the help of some arc I create some material here is which type of arc I can create with the help of some carbon material. In this DC is preferred for carbon arc welding here, and low resistor we can have some graphite electrodes are used, thus capable of conducting more current. The negative electrode here is 3200 degrees centigrade, and the positive electrode is approximately 3900 degrees centigrade. If you can remember, you can write it, or else just write this. What's the process we can follow here? Ionization process. We can follow some DC supply, we can have some holder, clamp, electrode, and we can form some arc for the part of joining things of metals or workpieces. Same metal arc welding, we can observe those things now. Workpiece, and apart from this, we can have some filler material also there, coating. We can have some touching those two things, and with the help of some arc, those two things will join out. The materials may be like this. We can have some strike like this. There it can have some zigzag manner. These two things will join there. We can have some supply, whether it's an AC or DC. Electrode holder for the moment of free movement. Just touch those two things and join those two parts with the help of same ionization process. Same in terms of that particular carbon, I can replace with the help of some hydrogen. We use some which type of electrodes here? Tungsten. Don't neglect tungsten electrodes only. We can use it maximum. In terms of two tungsten electrodes inside the part, I can use which type of gas here? Hydrogen gas. Filler material is also there, filler rod, and we can create some arc. Cool molten material is there, base material. We can join those two things. Same if you can use some argon, krypton. Depends upon the parameters. We can choose different things. The main thing of hydrogen here is mainly two functions. What's the first function? It's a protective screen for the part of arc, and also it has act as a part of cooling agent for the glowing tungsten electrode tips. we can create some sort of, let it be these are the two workpieces. We can create some arc here stuck across these two things. There we can create some sort of heat. Yeah. Then we can join those two things. Same inert gas. In terms of hydrogen, I can place some inert gases. Molten only we can join. Yeah, this one also plays a crucial role in examination point of view. DC welding, AC welding. Yeah. In DC welding, I use some DC na. Just AC is converted to DC. At the time, I can use some rectifier or else motor generator sets. When I can use some motor generator sets or rectifier, the efficiency reduces. 10th point is correlated. The efficiency will reduce. Whereas in only transformer used for AC na, there is a efficiency always increases. The cost of the equipment is high for DC, whereas this one is cheap. Arc stability is more, whereas this one is less. The heat is uniformly distributed for DC, whereas this one is non-uniform. Why means the waveform may be like this now, alternating. Both bare and coated electrodes can be used, only coated electrodes are used. The operating power factor is high, cos phi value is high for DC, whereas this one is low. Coming to the safety wise, it's a safer, it's a somewhat dangerous. Why means we can have some high voltages, no load high voltages. The consumption wise, it's a 5 to 10 kilowatt hour per kg. This one is only 3 to 4. Arc flow occurs in DC, whereas in this AC welding, we can't cut that arc flow. That's it. These 10 points plays a crucial role in terms of DC and AC welding. Finally, we'd like to conclude those things with the help of some resistance and arc welding. Resistance welding is only for the part of which supply? AC supply. This one is for both AC as well as DC. The heat developed is mainly due to the part of which thing? Flow of current in contact with the resistance. What's that law? Joule's law of heat. The heat developed is mainly due to the striking of arc between the part of electrodes workpiece or else electrode to electrode. We can create some arc. The temperature attained by the workpiece is not so high, whereas this one is high. External pressure conformably required for resistance, whereas there is no external pressure. Filler material is not required for this particular one. Filler material, obviously, we can use it there. Metal also we can use it. It can't be used for repair works, whereas we can use it for repair works in the household purpose. The power consumption is low. Operating power factor is also low. Power consumption is obviously high. Power factor is also high. Bare roller or flat type electrodes are used. It's not consumable. Whereas consumable, both non-consumable is valid. Bare or coated electrodes are used now. That's the main thing. Don't forget the thing. We can use some Joule's law of heating I square RT, whereas this one ionization process. That's it. Make a note. It's a simple question. If you can't remember anything, just go through the Joule's law of heating and ionization process. That's enough there. Both type of weldings. And one more thing. In resistance, it saves it only for AC, whereas arc we can use both the things so for AC as well as DC. In terms of resistance, we can use some transformer compulsorily. Yeah, that's for today. Thank you for watching my class here. If you like it, please subscribe to my channel here. This one is my channel name. Thank you. Thank you one and all.